Hello, I'm Connor Doyle. I'm going to be presenting part three, which is Newton's method. In this section, it is asking us to identify what the S infinity will be, knowing the initial population size, or n. We can find the S infinity knowing the initial population size through using Newton's method on the equation. Newton's method is defined by xn plus 1 equals xn minus f of xn over f prime of xn. So basically the xn is the initial guess, which is given to us as 100. We apply that to this formula basically, so it's just a plug-in. So the original equation that we have is x minus 8,000 ln x equals negative 48,605. We're able to apply Newton's method to this by S of infinity equals 100 minus 8,000 ln 100 plus 48,605 over 1 minus 8,000 over 100. We're able to apply that, and then this gives us an estimate for what S of infinity will be using the reciprocating calculator function, which gives us the estimate of approximately 461 people. This is a really valuable thing because we're able to use this and figure out how many people are not going to get infected in the SIR model. So we're able to apply this using different population sizes. The only differentiation is that we need to add this initial population to our initial guess of 100. That is the only differentiation, which allows us to get the S infinity is approximately 164 people with a 48,000 person or 45,000 person initial population. Initial population of 25,000 will be approximately 1,271 persons not infected, and then S of 0 of 5,000 gives us an approximately 4,839 persons that don't get infected. Interestingly enough, not many people get infected with smaller population sizes, which I thought was super interesting. The next step here is finding the recovered population, so figuring out how many persons are recovered after the disease has run its course. We use this by taking the original equation, which is ST plus I of t plus RT equals n being the initial population, and then S of t, I of t, and RT being the susceptible persons, the infected persons, the recovered persons, all of them added together. So at S of infinity, we can assume after the population has run its course that the change of I is 0, and infected persons is always a changing group. So if the derivative of that is 0, that means that there's no persons in the infected group. So that means that I of t is 0, which means that we can cancel out that I of t, which just gives us S of t plus R of t equals n. That allows us to, knowing S of t at S infinity using the initial population size, that we can subtract that coefficient over to the initial population size, subtract it from that, and then we get the recovered person's population size. Thank you very much for listening. I appreciate it. Hope you have a great day.